Welcome to Robotics Unleashed, December's Breakthroughs. In this episode, we explore the latest advancements in robotics research, focusing on 38 papers published in December 2025. From rapid simulation to safe human-robot interaction, these studies are actively shaping the future of intelligent machines. Stay tuned as we decode key innovations and spotlight our featured paper of the day. Today's presentation maps the robotics revolution, guiding you through the expanding frontiers of the field. We will provide an overview of robotics' evolving landscape, thematically analyze 38 influential research papers, and spotlight major advances in simulation, learning, and safety. The session includes deep dives into 3 seminal studies and concludes with forward-looking perspectives and actionable takeaways. Robotics operates at the powerful intersection of intelligence and action. This field fuses artificial intelligence, engineering, computer vision, and language technologies to build machines that can perceive, decide, and act in the physical world. Robots are now impacting homes, industries, healthcare, and even space exploration. Progress in robotics bridges abstract AI theory with real-world consequences, making safety, adaptability, and effective human collaboration more crucial than ever. The first major theme centers on foundation models and video-driven robot policies. These foundation models function as versatile toolkits for robots, enabling them to generalize knowledge across multiple tasks and environments. Research by Pai and colleagues demonstrates that video action models significantly enhance sample efficiency. Zhang and collaborators illustrate how video-based planners facilitate rapid adaptation. Wang et al. Leverage human egocentric video to improve robot perception. Collectively, these advances allow robots to acquire a broad range of skills from extensive datasets, moving toward more adaptable and generalizable robotic intelligence. Our second theme examines simulation and synthetic data, which are transforming the scale of robot training. Shang and colleagues introduce cs.RO, a system capable of generating hundreds of complex 3D scenes within minutes. Jane et al. Present Polaris, which effectively bridges the gap between simulated and real-world environments. Procedural scene generators now accelerate safe and scalable robot training, while neural reconstructions, digital twins built from video scans, provide diverse and realistic environments. These innovations enable robust, data-driven learning for robots poised to operate in the real world. The third theme is the integration of vision, language, and action, enabling robots to interpret instructions and execute tasks in real time. Su et al. Present vision-language action models specifically designed for autonomous driving. Liu and collaborators develop efficient frameworks for aerial navigation based on natural language commands. Hu et al. Propose pre-training strategies based on mutual imitation between humans and robots. These advances bring us closer to building robots capable of following complex instructions and adapting dynamically, even in challenging and previously unseen environments. Long-horizon planning and hybrid learning from the fourth theme. Here, the focus is on mastering complex multi-stage tasks that unfold over extended periods. Hybrid learning approaches merge imitation learning with reinforcement learning, allowing robots to learn effectively from both demonstrations and trial and error. Li et al. Show that reinforced gen excels in long-horizon manipulation tasks, while Chen and team demonstrate one-shot learning for sequential operations. These approaches enable robots to break down large objectives into actionable steps, enhancing endurance and adaptability in real-world scenarios. Safety, trust, and human-robot interaction constitute the fifth theme. Predicting human perceptions of robot behavior is now possible using advanced language models. As shown by Smith et al. Kim and colleagues, introduce new safety metrics for robot vision systems, and Li et al. Propose remotely verifiable policies to ensure accountability. Robots must not only explain their actions, but also adapt to the needs of human users. Trust and transparency are essential for widespread, real-world acceptance of autonomous systems. Key findings from December's research indicate a significant leap forward for robotics. Shang et al. Demonstrate that cs.RO achieves a 234-fold acceleration in scene generation, fundamentally changing data availability for training. Jane and the Polaris team have notably narrowed the gap between simulated and real-world environments. Pai et al. Reveal that video action models offer tenfold improvements in sample efficiency. Hybrid learning methods, as shown by Li et al., yield up to an 89% improvement in long-horizon tasks. Collectively, these advances empower robots to generalize and adapt with significantly reduced supervision. Methodologically, today's robots benefit from several cutting-edge toolkits. Large-scale pre-training on multimodal data, including images, videos, and textual information, enables broader semantic understanding. Procedural scene generation tools facilitate scalable, diverse training environments. Hybrid imitation and reinforcement learning approaches empower robots to tackle complex tasks efficiently. Vision-language action integration underpins real-time coordination between perception, instruction, and execution. However, bridging the performance gap between simulation and the real world remains an ongoing challenge. Turning to seminal papers, the cs.RO framework by Jinghuan Shang and colleagues stands out. cs.RO rapidly generates diverse, collision-free 3D environments for robotic training and evaluation. The use of batch sampling and GPU acceleration results in a 234-fold increase in speed over prior methods. cs.RO models spatial relationships such as stacking and containment to produce realistic, functionally relevant scenes. By removing a major bottleneck in large-scale robotics training, cs.RO enables the creation of robust, scalable datasets essential for both training and testing next-generation robots. Another pivotal contribution is PolarIS, introduced by Arhan Jain and collaborators. PolarIS constructs digital twins of real environments, from short video scans, utilizing neuroreconstruction to produce realistic, interactive simulations. Its co-training approach blends real and simulated data, ensuring stronger sim-to-real transfer than traditional evaluation methods. This framework advances accessible and reliable benchmarking for robot policies, democratizing the tools necessary for scalable and reproducible robotics research. Paper of the day is Mimic Video Action Models for Generalizable Robot Control, authored by Jonas Pai and team. Video action models, or VAMs, are pre-trained on large video datasets, enabling robots to learn not just static associations, but also temporal dynamics and causality. This approach achieves 10 times greater sample efficiency and twice the convergence speed of earlier models. Robots trained with VAMs robustly generalize to new tasks and environments, marking a paradigm shift in learning from video rather than static images and text. Understanding cause and effect through video enables more adaptive and capable robotic systems. Looking ahead, several future directions are prominent for robotics. Closing the loop between simulation and real-world deployment remains a key priority, ensuring that virtual advances translate to reliable performance in practice. Enhancing safety, interpretability, and human alignment is crucial as robots become more autonomous. Democratizing access through open-source toolkits and community benchmarks will foster broader participation and innovation. Addressing long-horizon, adaptive, and collaborative tasks remains essential as the field moves toward trustworthy, generalist robots capable of benefiting society at large. This presentation was synthesized by blending advanced AI tools with expert human insight. Content was distilled using GPT 4.1 from OpenAI, with TTS audio generated via DeepGram and visuals produced using OpenAI tools. Every slide was reviewed by a human expert for clarity and accuracy, though some minor oversights may persist. Please consult the full references for comprehensive details. All citations and direct links to papers are provided for those interested in further exploration. Thank you for joining us on AI Frontiers. Subscribe on YouTube for more deep dives in the latest in AI and robotics research. Join our community. Your questions and insights are always welcome. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from the arXiv preprint server. From neural networks to quantum computing, we simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer: this video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv preprint server.